So let's go through the list of information like we have it. Amplitude. Amplitude is our coefficient of the trig function, so the number multiplied with the trig function. So that would be 3. Remember, amplitude is always positive. If there were a negative in front of it, what would it do? Flips the graph. Okay. Period. Normal period is 2 pi. You divide by the coefficient of x. So that gives us pi. How do we find the count by? Period divided by 4 for the 4 quadrants. Do I have to do an interval on this one? No. You have to do an interval if you have something added or subtracted in your aim. If you are not sure if you need it, just go ahead and do it. It certainly wouldn't hurt anything. But you could leave that off on this problem. We always set 0 less than or equal to your argument less than or equal to 2 pi. Divide by 2, so 0 less than or equal to x less than or equal to pi. So this just tells me we're starting at 0 and ending at pi. You have to have that interval when you're moving left and right, otherwise it's just optional. The one thing we have not looked at yet, what would this -2 do to my graph? Down 2. Okay, let's graph. Okay, I am starting at 0, counting by pi over 4. So pi over 4 plus pi over 4 is pi over 2. 3 pi over 4 and pi. I did ask for 2 periods, so can I go ahead and just add on 4 more points? Keep adding my pi over 4. That would give me 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. And 8 pi over 4 is 2 pi. Okay. When you have to move up or down, what I want you to do is go to that point, so we are going down 2, and I want you to draw in a dashed line. Because my entire graph has shifted down 2, my graph is going to oscillate around -2. So -2 is now like my 0 mark, and then we're going to be going above and below that. So my amplitude is 3. That means I will be going 3 above this line, which is to +1, or 3 below this line, which would take me to -5. Okay, so now if we start graphing, we're looking at cosine. Cosine starts where? At its high point. So from this line, 3 above that would be at 1. Then it comes down to 0, which is on my dashed line. Down to -5. And back up. Any questions there? Let's try a couple more. Amplitude, 2. Because the negative in front of the 2, I know my graph will flip. Period, be 2 pi divided by 3. Count by, period, divided by 4, and you get pi over 6. Do we have to do the interval this time?
Yes.
Yes. So we would say 0 less than or equal to 3x minus pi less than or equal to 2 pi. Solving for x here. So we would add pi to everything. So pi less than or equal to 3x less than or equal to 3 pi. Divide by 3, so pi over 3 less than or equal to x less than or equal to pi. What else is happening on this graph? What's that doing? Up 4. It might be in the front, you might have a +4 written on the back. I kind of bounce around and just try to show you both ways. So just be prepared wherever I might put that term. Okay, so now we can graph. My first point is at pi over 3. It's like 60 degrees. And I'm adding pi over 6 each time. So pi over 3 plus pi over 6 would be 3 pi over 6 or pi over 2. Plus pi over 6 would be 4 pi over 6 or 2 pi over 3. 5 pi over 6 and 6 pi over 6 is pi, which is where we said the first one should end. I did ask for 2 periods, so let's go ahead and just tack on 4 more points. So plus pi over 6 would be 7 pi over 6. Next would be 8 pi over 6, which is 4 pi over 3. 9 pi over 6, so 3 pi over 2. And 10 pi over 6, which is 5 pi over 3. What do I need to do next on my graph? Up 4. So I'm going to positive 4. I'm going to draw in my axis there. My amplitude is 2. So you're going to oscillate between 2 above and below that line. So we're going to be bouncing back and forth between 2 and 6 here. We're graphing sine, which starts at its 0 point. So at pi over 3, you are on that dashed line. You're at 4. Sine typically goes up next, but we flipped. So at pi over 2, you're going to go down to 2 and then back up. would like for you guys to try one on your own before I stop today. So here is your problem. Should get an amplitude of 2, period pi over 2, count by pi over 8. Your interval should start at negative pi over 4 and end at positive pi over 4. And our graph is going down 1. Disagree with that information? So start at negative pi over 4. Add pi over 8, that's negative pi over 8. Add pi over 8 and that's 0. Pi over 8, pi over 4. For 2 periods, you need 4 more points. So 2 pi over 4 would be pi over 2. 3 pi over 4, 4 pi over 4 is pi, and 5 pi over 4. We are going down 1. So at negative 1, you draw your dashed line. Amplitude is 2, so you'll be going 2 above that, which would take you to positive 1. Or 2 below that, which would take you to negative 3. We're graphing sine, that starts at its 0 point. We didn't flip or anything, so then you go up to 1, back down.
So pi over 2, 3 pi over 8.
Did I start adding pi over 4? I did. I added pi over 8 until I got to here, and then I started adding pi over 4 for my points, didn't I? So those are off. Thank you. We're adding pi over 8, so this would be 3 pi over 8, pi, 5 pi over 8, and 6 pi over 8 would be 3 pi over 4. Is that better? So here's what I want to do. At the end of section 2, I'm going to give you the homework for this. And if we could, I would like to go to our graphing handout and just draw the graphs for tangent and cotangent. Then we'll pick up with actually doing examples of those tomorrow. Okay, so write this homework down and then get out that graphing handout I gave you the first day. We've only done sine and cosine on it, so we're going to look at tangent and cotangent next. Is a little bit different, and we will talk about why. But let's go through these. Let's just start at 0. It's kind of in the middle of our graph. But tangent of 0 is 0. Pi over 4 is like 45 degrees, and tangent is 1. Pi over 2 is 90, tangent of 90, undefined. 3 pi over 4, that's like 45 degrees in quadrant 2. In quadrant 2, tangent is negative, so we would get a negative 1. If I went to pi, we get y over x is at 0. Okay, if we go the opposite direction, negative pi over 4 is just like 45 degrees, but it's in quadrant 4, because you spun the negative direction. Quadrant 4 tangent is negative, so that would be a negative 1. Pi over 2. Negative pi over 2 is just down here. Negative 1 over 0 will be undefined. Negative 3 pi over 4 is just like pi over 4, but in the third quadrant. Third quadrant tangent is positive, so it'd be positive 1. And negative pi is the same as positive pi. You're at 0. Okay, so I picked some weird angles here, but let's start plotting these. The points I put on your axis, let's make those our pi over 2s. So this is pi over 2, pi. Instead of going all the way to 2 pi, from 0 to 2 pi, I went the negative direction. The pi over 4s would be halfway in between all of these. So tangent at negative pi is 0. At negative 3 pi over 4, that would be right here. You're at 1. Negative pi over 2 is undefined. What that means is we are going to have a vertical asymptote. Negative pi over 4 was negative 1. At 0 it was 0. Pi over 4 was 1. Pi over 2 is undefined, so we have another asymptote. 3 pi over 4 was negative 1, and pi is 0. What this graph looks like, if we picked more points, we would get to this. It's a curve, and they approach the asymptotes. So vertical asymptote you're getting closer and closer to without actually crossing. So our graph looks like this. Now, we stopped our graph at negative pi and pi, but you wouldn't have to. It's just going to keep going. Same pattern continues. The reason I didn't just go to 0 to 2 pi is I wanted you to see, if you look from negative pi over 2 to positive pi over 2, you have one nice, complete piece of the tangent graph. This is the thing that just keeps getting repeated. So the period for a tangent is different than sine and cosine. Sine and cosine take 2 pi before they start to repeat themselves. Tangent starts to repeat itself after this. Tangent has a period of pi. After a length of pi, it starts repeating what it was already doing. So in general, sine and cosine, we're always going to graph those from 0 to 2 pi. Tangent, we are going to go from negative pi over 2 to positive pi over 2. You could really pick, you could go 0 to pi if you wanted. I just like negative pi over 2 to positive pi over 2 because then I don't have to break my graph in the middle and put an asymptote in the middle of it. It's just a nice smooth curve. So we'll talk more about that tomorrow. Domain of this, what can x not equal? The negative pi over 2, positive pi over 2, this would keep going. I'm just going to start listing some values. Dot, dot, dot. It's like negative 3 pi over 2, negative pi over 2, pi over 2, positive 3 pi over 2, and the pattern keeps continuing. Basically, all of those values, we get a vertical asymptote. The range, what y values does this graph hit? All of them. So it's just negative infinity to positive infinity. Is this graph even or odd? Odd. Symmetric to the origin. That's what we talked about with sine. And what that means is if you have a tangent of negative x is equal to a negative tangent x. So you could pull that negative out in front. Let's just stop here. We'll look at cotangent and then graph variations of these tomorrow, and that'll give you guys quite a bit of time to work on your homework.